The next thing that we're going to do is connect our tangential velocity to our tangential acceleration to our angular acceleration. So here we go. In the last video, we talked about our radial velocity. Okay, and that's when you have something swinging around like so, and it's moving in this direction. We're going to have a tangential, or we're going to have a centripetal force that's going to act towards the center. Centripetal means center-seeking force, and so there's an acceleration associated with that. If you're driving around the bank of a curve, or if you're driving around a curve, it's banked a little bit, but we basically have the frictional force and probably even a gravitational aspect of the force center-seeking. So it keeps you from flying off the road. That's basically what we're talking about. Okay, so let's go ahead and look at this. Remember that we had our angular acceleration, and let me make sure that I am treating this properly. Remember we had our velocity, tangential velocity, equaling to our angular velocity times our radius. So let's go ahead and take the change in that. So now we're going to have r delta omega. And in this particular case, we are not changing our radius, so we're just allowing the delta to go all the way through. And if we say we have a delta v over delta t, this will end up being r, and since r is not changing, the delta t will only apply to our omega. So now we end up with our tangential acceleration is equal to r times our angular acceleration. Okay? So in the last video, we found that our radial acceleration was just equal to, and let me go back to this, here it is, it's vt squared over r. So it's, oh, let me look at that again, I forgot it that quick. Okay. Vt initial over r, and this is squared. So when you're thinking about acceleration of an object, let's just say that you are slinging this around. You're going to have an acceleration in this direction. This is our tangent acceleration. And then you're going to have an acceleration going back here. This is our radial acceleration. And between those two, you're going to have a resultant acceleration. So the way we find our resultant acceleration is just with Pythagorean theorem. And that's going to be our tangent squared plus our radial squared. All right, so this is going to pretty much end our theory when it comes to talking about angular acceleration, the tangential connection, our radial connection. So we'll be using this in our experimental activity. Okay, and we'll be using this idea here as well. We're going to be using the tangent velocity, r omega. We're going to use this one, and we'll use this one in our experimental activity. Okay? There we go.